Hello, it's Scott Manley here. Last week while travelling home from Southern California, I made a bit of a diversion so I could stop at Mojave Air and Spaceport, also known as Rutan Field, so I could visit this absolutely beautiful aircraft which is currently doing test flights over the Mojave.
This is the XB-1, built by Boom Supersonic.
It is a 3-engine supersonic civilian plane. I say supersonic. They have yet to actually take it supersonic because they are only on their 4th test flight. On that flight, they took it up to 16,000 feet and flew it at Mach 0.6, but before then, there's a lot of stuff you have to check, such as the landing gear. Make sure that it can deploy and retract correctly in flight. Collect data on all your avionics. Look at how the wing performs. That's what all those little telltales are over the wing surface. And of course, when test flying experimental aircraft, takeoffs are optional, but landings are required. Now, I didn't actually get to see a test flight because that happened when I was out of the area, but I did get to visit the XB-1 in its hangar as it was undergoing a post-flight check. During Flight 4, they had not only taken it up to Mach 0.6, they had also pulled up to 2.5 Gs, and that was the highest they'd seen on the airframe so far, so they wanted to just verify that everything is good. It shouldn't be a problem, but this is why you're doing test flying. And by the way, my guide for this little visit was the test pilot himself, Tristan Geppetto Brandenburg.
So you guys have gone for a delta wing, but you've got a little horizontal stabilizer down below it as well. And that's a really tiny rudder, I'm going to say.
It's actually a rather large rudder.
Okay, so wait, the whole thing is a rudder, and then there's
all the yellow part is all rudder.
Okay, I'm just saying that rudder's about the same size as the one on my plane.
It's quite a bit more rudder than we need.
Oh, okay.
Yeah.
Yeah.
The size of the rudder is driven by a one-engine inoperative scenario. So if we lose a rudder on takeoff, or sorry, not a rudder, an engine on takeoff, then the rudder is what keeps us upright.
Right. So if you're getting any asymmetric thrust and they're so close together, that's not going to be a big deal. But I guess on the big scaled up version, your engines are going to be
more of a concern. It's definitely a concern on this. It's one of the things I practice every time before every flight. Is
like, how does this thing slip for a landing?
How does it slip for a landing? It doesn't really slip.
It doesn't.
It kind of rolls. Side slip is not a friend to this airplane.
I don't think it would be. But so yeah, I mean, we've got these these delta wings, leading edge extension, so you're getting like pretty good high angle of attack, and so you're coming down just a lot of thrust, high angle of attack.
Yes.
Okay. And the landing speed, I think I saw it was about 165 or something.
I don't think we've had it that low yet.
Okay. Okay.
I think on the last flight I touched down below 165, but the approach was 172 knots. So.
It's like, I think I managed to get mine up to 150 in a dive. So it's so beautiful though. Like the lines on this are very sweet. So there's basically a cockpit, you've got their all electronic panel. There is like room for somebody, but they'll not be operative, right? They'll be like a back seat.
So we've filled that up with avionics.
Yes. But like I heard that at some point you could put investors in the back.
The original design had 2 seats back
there.
But
it was only ever intended to fly from the front.
Yes.
And so it looks like you've all used off-the-shelf avionics for this whole thing, for your panel.
So our MFD, our multifunction display, is it's commercial off the shelf, but it has our own software.
Right. Okay, so you get access and you can change all that.
Yeah, we write our own software, but then the backup displays are off the shelf.
Neat. That's pretty cool. And obviously got an air probe sticking out the front there. Now, presumably the final version won't have this air probe, right?
No,
this is just for learning, right?
Yeah, that's typical of a flight test asset.
Right.
So measuring airspeed, you use total and static pressure. Total pressure is pretty easy to measure. Static, depending on where you put it, you can introduce some air in it.
Right.
So you can see we've got some static ports on right above the nose landing gear. They're covered up with a black, it looks like a suction cup.
Yep.
But then we also have static ports up front, which are largely undisturbed by the majority of the airflow. So those are far more accurate, far more reliable than ones mounted flush to the
Right, and over time, you're just going to use the data from those to train those things so that the avionics can work with that.
That's how you would. We're going to fly with the nose boom.
This is permanent for this thing,
Yes.
right? Yeah. Okay.
The aircraft is powered by 3 J85 afterburning turbojets. This is an old engine design that started like in the 1950s. It powers the T-38 Talon and many other aircraft. They're actually quite available, and that's why they're being used. So these are fed by a trio of ramp intakes. You've got one on the center line, which is bringing air over the top, and 2 which are underneath the wing roots. Originally, they thought they were going to use the civilian version, the General Electric CJ610, but given that this is a test vehicle, they decided that the extra thrust of the J85s would be useful in pushing this to the limits and gaining more understanding of how vehicles operate. Incidentally, it was with great amusement that I noticed that the rear section of this high-performance supersonic aircraft did not use flush rivets. Now, you could absolutely argue that this far back, the boundary layer would be so thick that the aerodynamic drag that you would save would be easily offset by the extra mass of those flush rivets. But the truth is, if you've got 3 J85 engines on a plane this size, it doesn't matter. The air is getting out of your way one way or another.
But yeah, so far you've done 4 flights?
Yes.
Maximum speed 0.6?
0.61.
0.61. And how many more flights before we get up to supersonic?
That's a good question. We're figuring that out.
Okay.
As many as it takes to do it safely, but as few as possible, if that answers your question.
Yeah. And I'm guessing you fly out of Mojave, but you actually do most of the flights over Edwards?
We do. We've got a letter of agreement to operate in the restricted 2508 and 2515 airspace.
Right. So when it's hot, it's because of you guys sometimes, right?
What's that?
When you're asking, like, is the area hot? It could be you guys, right? It's not necessarily military. I mean, that's good because if there was a problem, you have runways right there. And although this thing probably doesn't glide particularly well.
No,
not with that tight. I mean, I saw you were above the shuttle runways, and we all know how well that glide, right?
Yeah, it would probably be similar.
So your experience, you're like a 2,500-hour pilot with U.S. Navy?
Yes.
Yep. And a bunch of carrier landings. What did you fly?
Primarily Super Hornets.
Super Hornets.
I've flown the Legacy Hornet as well, and I'm a reservist with VFC 204 out of New Orleans.
Okay.
Flying the F5 as an adversary.
Oh, you're flying the F5 as well. That's interesting. Man, I can only dream of this stuff.
It's not bad.
It's like one of these things I thought of as a kid, but no. Video games only for me, unfortunately.
Of course, you probably know that the XB-1 is just a test product. It's something the company is building to demonstrate that they have the know-how for their main goal, which is the Overture. This is a passenger airliner which will go supersonic. Yes, one of the great tragedies of my lifetime is that technologically the world has taken a step backwards. When I was young, you could fly on the Concorde, you could cross the Atlantic in 2.5 hours if you had the money and your time was more valuable. Unfortunately, our dreams of speedy air travel were destroyed by people's desire for cheap-ass plane tickets.
As in sitting on your ass for a long time.
Big planes carrying lots of people flying subsonic. But while the demand for Concorde was small, it never went away.
And so, 10 years ago, Boom Supersonic was founded,
with the intent of bringing those dreams back to reality. And that's what the Overture is supposed to be. And while Concorde took massive amounts of government-backed research in France and the UK, Boom believe they can do this as a relatively small aviation startup. Their design is going to be slightly smaller, slightly slower. It'll fly at like Mach 1.7, but it'll also be designed with 21st century technology and understanding of what makes an aircraft maintainable. And with modern engine technology, it's hoped there will be a whole lot more efficient. Concorde needed those afterburners for takeoff and to get it up to cruise speed. The engines being developed for Overture are called Symphony. And like the, Olympus engines on the Concorde, this is a classic, two-spool turbojet design in the middle. But unlike the Concorde, this doesn't have afterburning, and it has a moderate bypass section at the front. So Modern jet engines, they get more efficient by having this big fan disc at the front and blowing air past the engine. High bypass engines are more efficient. But on the other hand, having a massive fan disc on the front of the engine does tend to make them drag air, so you're not going to use these in, supersonic aircraft. So having the moderate bypass helps with their efficiency. Even then, though, they're still having to go faster, and the drag law goes as velocity squared, so they're going to have to burn more propellant. On the other hand, they are going to be able to fly higher, about 60,000 feet, so there'll be a bit less drag up there. And so their official estimate is that they will take about twice the amount of fuel per passenger compared to a conventional subsonic jet. Of course, that's yet to be tested, and we'll see how it actually goes. Now, the interesting thing about this was that if you look at all the airliners in the world, there's only a handful of engine manufacturers, primarily GE, Rolls-Royce, and Pratt & Whitney, are responsible for the engines that are used on the world's commercial airliners, because in the passenger world, you want to get the cheapest tickets possible. And these engine manufacturers have just spent years optimizing their engines to be as efficient as possible. None of these manufacturers are involved with the Symphony. While they're doing a lot of the work on their own, they are working with companies like Kratos and Florida Turbine Technologies, who have experience with military jets, but not the high-efficiency jets used on passenger planes. And you might think, well, that has immediately doomed this, because if every other airliner uses a jet from these companies, how can Overture possibly compete? Well, again, it comes down to speed. Right now, GE and Rolls-Royce are not competing in this market. So the fact that they absolutely dominate passenger aviation at slow speeds doesn't mean that they are unassailable at supersonic speeds. Still, building a supersonic airliner is a massive technological challenge, and they are going to need a lot of runway. The XB-1 is a small step on this to demonstrate that they have the competency to build a supersonic aircraft.
And it really is just a test bed so Boom can get familiar with working in the supersonic regime again, right? And this is a sort of set of experience that's largely been confined to, large government entities and companies that are much more friendly or much more interested in what the airlines want, and the airlines want slow, efficient planes. But, right?
Yeah, this the main value of this aircraft is not so much in the aircraft itself. Like you said, supersonic airplanes are typically built by governments. Right. It's a hard thing to do. So for a startup company to do that is rather historic. And the main benefit of this is it allowed us to build a team in the process of building.
Right. Build the experience in house. Right.
And build the safety culture as well.
That's true, yeah. Because if you're pushing the limits everywhere, it's not that the engineering is necessarily difficult sometimes, but that you're pushing up against hard margins that make it difficult.
Yes, it's an inherently difficult thing that we're trying to do, and we've got a very good team, and we're doing it.
So how big is Boom right now then?
I'm not really sure.
You're not really sure. Yeah. Okay.
I don't want to give you a bad number.
No, okay, that's fine. I mean, I'm just imagining, you say startup, and all I just suddenly thought of is like, yeah, I remember startups, and we would talk about the runway to get, the thing profitable. And I imagine that building a supersonic airliner requires a bit more runway than anyone could think of. Just like this probably needs a bit more runway than most.
And so, speaking of runway, there is an interesting way that this differs from Concorde. One of the things about supersonic aircraft is you want them to be sleek, and you want this nose to be sticking a long way forwards. But when you're landing these aircraft with delta wings, one of the nice things is they can have a very high angle of attack because of the way the air spills over the top of the wings. But that makes it very hard for the pilots to see the runway ahead of them. And on Concorde, you had the famous droop snoot, the nose that would descend down so the pilots could see in front of them.
One of the interesting things to point out is you may notice like how low in the fuselage the pilot sits. Like typically, like if you look over at the T-38 or the Impala,
right,
the canopy looks like a bubble sitting on top. So I can't see out the front of it, especially when I'm landing.
So you're just looking at your screen, yes. Right?
So you can see our two cameras on the nose gear. They've got a remove before flight flags.
Right, I see the little, yep.
Yeah, so because they're so safety of flight critical, like
There's two of them?
need those to land. Yes, there's two of them. They're separated physically. They have separate wires going to separate displays, so they're truly redundant systems. And this is a proof of concept that, hey, it is possible to land an aircraft at these speeds without reference to visible reference to the runway itself.
Right. Because the Concorde, for its descent, its landing, it would have the nose that would flex down. And it was an amazing, fascinating piece of engineering, but it was in an era before we could have TV cameras this small and displays in the cockpit. And so those displays are primarily for landing. I'm guessing the angle of these cameras is like your target AOA or whatever, right?
Yes, so we fly a 12-degree angle of attack approach on a 2-degree glide slope. So those are angled down such that they're pointed at the runway, like the center of the runway. If I'm on glide slope, on speed, will be right in the center of the display.
So, like, you're landing this all visual, right? You're not following an ILS or anything? Or?
We've got a quasi-ILS. It's GPS derived.
Right,
It's certainly not certified by any means.
Right.
It's a guidance to get me to have the runway on the display. We also have what we call a landing signal officer standing near the runway. He was a naval aviator, F-18 guy, just like me, and then spent years standing on the back of an aircraft carrier talking to guys as they came down. So
yeah, it's more that I see that, like, all the instrument approaches that I see are like about 3 degrees. So 2 degrees, that's low.
2 degrees is low.
Sorry, it's not. Yeah, it's very shallow.
It's a shallow approach. A number of reasons we do that. The J85 engines are notoriously laggy, so it's a shallower approach. It makes the engine response time a little bit better. It also makes the flare maneuver a little bit more gentle. So a 3 degree, you think about like flying your Cirrus as you reach your flare point, right? It's a side stick,
quite a rotation. Yeah,
it's a lot of rotation. We really don't like abrupt maneuvers in this. We like a more gentle thing, especially when we're responding to voice comms. There's an inherent time lag between what the LSO is seeing, to what he's saying, to what I'm hearing, to how I'm reacting. So a 2 degree glide path is a bit more friendly to that than a 3 degree.
But your nose is up already above that anyway, so there is a flare right at the end still, I guess. I guess
we increase the angle of attack to 14 degrees in the flare, which
basically takes out your 2 degrees. Cool.
And so with that, the highlight of the visit was flying the simulator, also known as Spaceballs, the simulator.
Yeah, you're right. There's not much to see here.
So we've got it angled up at 12 degrees. This is basically our approach attitude.
I see it, yeah.
We didn't want the first time we felt like being angled up like this, or the first time we landed, to get used to a nose down attitude.
Yeah.
We're subconsciously pushing for it. But yeah, if you want to take off, it's all ready to go. So,
okay.
Just bring all 3 throttles up to, just push them forward.
Okay. So just slowly. Where's my readings here? I don't know how fast I'm supposed to do this on a.
I'll take you through it. And then that's the mill stop, so push harder on the throttles.
Okay.
There you go. Now you're in full afterburner.
So now I'm just about trying to keep pointed down the runway.
Yep.
What's my rotate speed?
150.
150, okay. Come on.
Nice. Easy. Perfect. Keep it coming.
Keep it coming?
Yep. There you go.
Okay, what should be my angle on this? Now, how do I get the gear up?
The gear handle right there.
Oh, yeah, of course.
Yep. Cool.
Okay. Right. Oh, now we switch.
Yep, because the camera's on the nose here, so now you can't.
Right, so now my nose is coming way up here. I should probably pull back on this a little.
If you want to. Best climb speed is 350 knots or so.
Okay.
We haven't expanded the envelope about that yet.
Okay, so where's my trim on this?
That's it.
That's it there, okay. Because I'm just trying to find out where my trim is. 7,000 feet. And you know what? I know I'm heading towards mountains. I think I want to turn towards Mojave.
Yeah, go ahead and start a turn.
Yep. And I'm guessing this is fly-by-wire and coordinates nicely for me.
No.
Nope, okay. Because I don't see any slip skid indicator here.
You got side slip here.
Okay. There we go. And there's a runway already. Crikey. We're up at 11,000 feet.
Yeah, this is that's California City right there.
Yep.
And then Mojave's back this way still.
Okay.
Of course, taking off, that's kind of the easy part. It's landing it, that's where the fun really begins.
Okay, so that looks like a 3-degree glide slope. I guess I'm high.
Yep.
So. And just left of center. I really want to correct that. Or right of center, sorry. There we go. Okay, let's put in a bit more power. Oh, I'm going to have to show this to my flight instructor.
Hey, looking good.
Yeah. Okay, so...
Right about here, you probably want to start the flares. Bump the throttles up a little bit, actually.
The throttle's up, huh? Okay.
All right, that's a good correction there. And then kind of hold what you got for a sec. All right, now hold the nose where you're at and start bringing the throttles back. There you go.
Okay, a little bit of wobble there. Oh, damn, I really get... Yeah, okay.
Not bad.
Right, now, where's... How fast do I start braking at?
You can start braking now.
Okay, is the toe brakes?
Yes.
Okay. My instructor's going to tell me I landed off center.
Yeah, I mean, you've heard the phrase that a good landing is one you can walk away from. I can assure you that phrase did not come from a flight instructor. Anyway, that is the XB-1. I'd love to go down and see it fly at some point, but really, I'm just hoping this is a successful, test campaign, and it does in fact translate into an operational supersonic airliner, because I would love for a small corner of commercial passenger aviation to return to the glory days of the 1990s. I'm Scott Manley. Fly safe.